All right, the fall semester has begun for me in earnest, and it's a bit like drinking from a fire hose all at once. So, just given my, monstrous workload that I'm going to be putting up with, I think we're going to have to stick to these short stream of consciousness vlogs for the time being. So, it's back to school time for many of us. I know the local elementary schools, local public school districts are starting back here this coming week. My nephew is going into first grade, and it comes time for the annual controversy over Common Core. And I want to just say a word in defense of Common Core math. I can't really speak to how well Common Core English is doing. Um, I will say that, like all forms of English pedagogy, it suffers from a lack of systematization. So nobody just goes out and says, look, here are the 13 vowels, 5 diphthongs, and 23 consonants that are most commonly found in modern English. Here, let's learn them all one by one. It doesn't sort of do that, and it doesn't talk about how spelling has changed over time. So, for example, why the letter Y has so many different pronunciations, even though, you could probably do that all in one lesson. So I can speak, though, much better toward the math requirement, both because of the amount of math that I do on a day-to-day basis in my own job, but also because I have taught during my brief period in elementary school. I have taught some Common Core math, and I think actually having done some Common Core math with the kids has made me better at doing math. So if it can, maybe make someone my age, or I guess I would have been about 24 when I did that, can make someone of that age and an adult good at math again, maybe it really is quite useful for children. So the common criticism of Common Core is, oh look, this is just, it takes too long, my kid doesn't understand it. Here's the old procedural way to get to a correct answer. Well, the problem with that is that it doesn't build in numerical sense. It doesn't build in a sense of, why you're doing anything. And I learned math by rote procedures. And when I hit algebra, and you have to be flexible with the manipulation of variables, I just couldn't do it. I was not able to do algebra. It was only in college when I started to get good at math again, because I had started to understand the necessary pieces of the flexibility required to do math. So my thinking is that, and you'll hear this a lot of pro Common Core math people will say, it gives people the mathematical flexibility, and it does do that. There's excellent examples of places where it gives you, tricks to solve it in your head that would just take forever to do pencil and paper. But from my perspective as a scientist, I think it better prepares you for actually doing the kind of math that most scientists do. So, for example, my master's thesis, and I've got a few videos that go through it, and I'll link one of those below. I dealt with an extremely complicated equation, which was not conceptually difficult. It was easy to understand up here, but just sort of writing it down and stating it, that was sort of complicated. And then, it had no analytical solution. It had no pencil and paper solution. It had to be solved by a computer. And in solving it by the computer, we had to tell the computer what to do. So this kind of work it's much less important to get the correct answer because the computer is going to do that for you, and much more important to be able to understand the nature of the problem and to understand how to tell the computer to do what it has to do. I think this goes together nicely with the people who are anti-calculator. Um, that's just silly, right? We because once you get to the upper aspects of math, for most people who aren't mathematicians like what we do, we deal with problems that are unsolvable by methods other than computer. So yeah, you just get a calculator to do it is a perfectly valid answer for us. And usually the intricacies in the math comes with telling the computer the best way to solve it. Programming the calculator becomes more the essence of math than the problem itself. And, granted, you might be able to do long division in your head, let's say, without a pencil and paper. Okay, impressive. Um, I'm, but in fewer lines of long division, I can write a Python script that can solve an integral. So this stream of consciousness rant ends with the idea that Common Core math equips people to have the number sense they need to work well at higher level maths. Sure, it might be a little harder for smaller level of math, but then just grab a calculator. And it all equips people to solve the problems they might actually face, the kind of training required for STEM fields. And the anti-calculator bias is just absurd. After you reach a certain level of math, the art becomes about programming the calculator to do the math. All right, so that's the end of this brief stream of consciousness rant for today, and I wish you the best. Take care, folks. Hi, I'm Tommy, and I'm a professional paleontologist. I'm also a philosopher and disability rights activist. Unlike most evolutionary biologists, though, I've had a lifelong obsession with the paranormal and the occult. Most of my videos concern the philosophy of magic and polytheism, or the politics of disability. Sometimes I talk about my actual research, but as that's my day job, I'm much more likely to just stick around and watch DuckTales. If you want to join me on my journey, friend, don't forget to like and subscribe, and welcome to Creepy Puppets Presents.